Her mom's the big one next to Hadley. See how there's like a whole bunch of space on both sides. Yep, that's because mine.
Okay. So we definitely did things with section 4.3.
What did we celebrate on Monday? Whose day?
Hey, be quiet.
Is it your birthday?
It's not.
What day?
Javon, can you have this argument with him later, please?
No, because I don't have Grace in any other class. Grace.
Hey, so we did 4.3 at the very beginning because, like I said, it requires you to have a working knowledge of sine, cosine, and tangent. Yep. But there are some other parts to 4.3 that we need to talk about.
You need more desks.
Use what's behind. Oh, you can't use what's behind you.
Don't help when Siobhan's halfway on mine.
Yep, I know.
Give me a second.
I
no longer have
Okay, I didn't want to make that big.
Yeah, we're good.
Okay, that's good. I'm glad to hear it. Okay, we talked about the unit circle the other day. You don't even have to write this down. Unit circle has a center at the origin and what? Radius of 1. Okay, so we ended up with this. This is the point XY. What was the length of this bottom side?
1.
X. What's the length of this side? Okay, so we had this triangle that we're going to, I'm just pull out and use the triangle here. Okay, so X and Y. So back in the day, somebody, I don't know who the somebody is, they were like, let's do some moving of things around. And they said, let's see what we can come up with that is true. So we know, don't write this down. It's already on your paper that you should have in front of you. Okay, you know that sine is equal to what? Y. And cosine was? X. And tangent was? Y over X. And cosecant is 1 over Y. And secant. And cotangent was? Okay, you have that written down. You don't have to write it down again. So they said, though, what if we got rid of the X's and the Y's? So just using this information, we can define tangent by doing some substitution. So they said tangent, you don't have to write this down either, it's going on your notes, okay, or on your paper. They said, hey, tangent is Y over X, but what's Y? This is not a rocket science question. What's Y equal to?
Sine.
Yeah. And what's X equal to? Cosine. So they said, hey, we could also define tangent as sine over cosine. Okay? There's reasons. We'll talk about it. Okay, so that is something called a quotient identity. So there are 2 of these. Why are you using your calculator? Whoops. Okay. So the tangent is equal to the sine divided by the cosine. There's something called an identity. Now let me pause and tell you what an identity is. This is the Mrs. Douglas translation of many math things. An identity is something that's true as long as it's true. Okay? So the technical thing is an identity is true for all of the values that is in its domain. Not very helpful. Let me give you an example of something that is an identity that you already know. Nope.
That's true.
That is true. So I'm sure that's true. This is a true statement, right? But this is what it means. It's true when it's true. You can't just pick random numbers and be like, oh, it's true. Right? It has to be a set of numbers that actually works. Okay, it has to be a number that actually works. So 3, 4, and 5, that is a true statement. So it's true as long as you're not doing stupid stuff and being like, well, it's true if it's 4 and 9 and 13. It's not true. Okay, so it's true as long as you're working with something that's true. Okay, that's an identity. Anyway, we use identities for other things. Okay, we use identities for other things. This is called, like, we call it Pythagorean theorem, but if you were to look in your book, it's also called the Pythagorean identity. Okay, because it's just a true thing. Now, there's another quotient identity, and the other quotient identity is the one for cotangent. Okay, so if cotangent, I don't think I can get this all on one page. Cotangent is x over y. So cotangent is what? Yeah, cosine over sine. Okay, now there are reciprocal identities also coming from this over here. I'm going to actually leave space over on the left-hand side. So it's kind of start in the middle. So cosecant, if it's 1 over y, which it does say on your paper, if it's 1 over y, what is that going to be? 1 over what? Yeah, 1 over sine. That's what it means to be a reciprocal. When you have 1 over, that's a reciprocal. So then what's secant? No. We talked about this when we were talking about solving. What are you allowed to do when you have something on the left and something on the right in a fraction? I said that wrong. Something on the left and something in the denominator. You can flip them. So sine itself is equal to 1 over cosecant. So cosine is going to be what? 1 over secant. Correct. Now, we're doing reciprocals. Cotangent is the reciprocal of tangent. Okay. And then tangent is 1 over cotangent. Okay, now, similarly, again, you do not have to recreate this, so do not panic. But somebody else was like, hey, what if you use the Pythagorean theorem on this triangle here? Okay, so if you use the Pythagorean theorem on this triangle here, what statement do you get? What's 1 squared? 1. Okay. So then they said, hey, let's replace sine and cosine with x's and y's. Okay, so it would be cosine squared. Nope, you don't write this down. Plus sine squared equals 1. Now, a couple things that you need to know. Okay, this you might want to write down. Okay. Yeah. We'll switch it to theta when put on our sheet. When you see something like this, so the sine of something, I'll switch to theta because I would rather anyway. Okay. So we've got the sine of theta squared. It gets written like this. So it's written on because what that does is it lets you get rid of a set of parentheses. Otherwise, you're going to get into a situation where too many parentheses. So we'll write it. I'll show you what it looks like. Just a second. Actually write it like this: cosine squared theta plus sine. That's how you say it. Sine squared theta equals 1. But if you are putting it in your calculator, it's not possible to put the squared in between the theta. So you have to write it like this. So if you're going to put it, so let's say I was doing the sine let's say I was doing this, sine squared of 30. Okay, well, sine itself is not a number. So if you were doing this, you'd have to put it in your calculator like sine of 30 and then squared. Okay, so it's important to know that these two things mean the same. This is how we write it. This is how we put it in our calculator. If you take calculus class, we write it like this, but we have to use it like this all the time. Okay, so if you talk to somebody and they would be like, oh yeah, we have to rewrite that, assuming they remember anything that I taught them. Okay, so this guy is called a Pythagorean identity. And actually I like to put sine first just because that's the way my brain works. So it's sine squared theta plus cosine squared theta equals 1. Okay, so it comes from, you don't have to know where it comes from, but it comes from the unit circle using that x, y, and the 1. Now, again, I heard Javan say, he was like, well, who comes up with this stuff? They didn't have anything else to do. Okay, so, I lost what I want to say. Yikes. This is really like the big dog. This is the big dog of the identities. If you can remember this one, it's going to help you out a lot. But somebody said, this is how things happen, okay? Don't write this down. But somebody said, hey, what if I came through this guy here? I'm going to write him down. Sine squared plus cosine squared is equal to 1. I do want you to pay attention to this because it contains some stuff you're going to have to understand. Anyway, somebody came through and was like, what if we divided everything by sine squared? Okay, that is mathematically legal because you're doing the same thing to both sides. Okay, so what is this equal to?
1.
Yeah. Now, this is, you don't have to rewrite it, but remember what something squared means. It means 2 of them. This is a cosine and a cosine over a sine and a sine. If you go over back to your paper here, this is a quotient identity. What is cosine divided by sine equal to? Nope. Cosine over sine is cotangent. And so there's 2 of them though. So this is cotangent squared. Okay. So what's 1 over sine squared equal to? You have to look at reciprocal identities for that. 1 over sine is not secant. Cosecant. And it's 2 of them, right? There's 2 sines, so there's 2 cosecants. Cosecant squared. Okay?
So we just subbed out sine and cosine for cotangent and cosecant.
So and the reason that we do that, Javon, is because this is a fraction and this is not.
Yeah, but why make a fraction in the first place?
Because somebody, whoever the random somebody is, said, let's divide everything by sine. So that's why the fraction was created. So
We really need to put that back in whatever. 300s.
Just go back in time before they agreed on that.
okay, that needs to be written down. Write it down. Okay? That is also a Pythagorean identity. We do not use it as much, so it is a little dog. Also, little dogs come from big dogs, so it also works biologically speaking. What did it? Okay, so same person. Same person said, oh, what happens if we divide by cosine? Okay, so Yep. Tangent squared. This is tangent squared. Yep. And a 1. Very good. Okay, again, you do not have to come up with these, but you gotta have to use them. Also a little dog. Okay, so here's what I want you to know. Okay, here's what I want you to know. You go on to take anything trigonometry related or math beyond high school, and you go to college, and you're like, hey, oh, I know that's the little dog. People will not know what you're talking about. Okay, this is a Mrs. Douglas class thing.
Not even the college professors.
No. I mean, they'll know it, but they will call them Pythagorean identities. Nobody wants Pythagorean identities like 17 syllables. Nobody wants to do that. It's a big dog. That's 2 syllables. Okay? Yes, thank you. Big dog.
Little is 2 syllables. That means.
I said big dog.
No, but little dog is 3.
Thank you.
So it's too many. That's why.
Would you rather go with Pythagorean identity, which is like 7? Okay, there you go. It's 9. Yeah. Okay? So listen. Whether you take a trigonometry class in college or not, you'll have to use this. In my class. If you were to take a trigonometry class or a class that involves trigonometry in college, you gotta have to use Pythagorean identities. Okay? I just don't want to spend so many hours of my life calling them Pythagorean identities. I'd rather just call them the dogs, because that's the way it is.
So I say 1 to 10. How much is calculus and stuff?
I didn't take it.
What'd you say?
How much is calculus and stuff?
If you whine about it, just don't take it, okay?
I'm gonna take it if I'm the one about it.
Okay. There are a couple ones that we're not going to talk about. No, a couple that we're not going to talk about where they came from. We can get into it at some point in time. We're just going to write these ones down.
This is like.
Okay. So, if you go back to, this is an ask because it's been a while since we talked about it, but do you remember the definition of even and odd function? Yeah.
Yes, the end bit.
No.
Nope.
I mean, that is true
To an extent.
to an extent, but an even function is if you plug in f of negative x.
You get positive.
No, it's the same. It's just f of x. It's the original. If that's an even function, don't write this down. It's okay that you don't remember. Okay?
I remember.
F of negative x is negative f of x. That's an odd function.
It
So-
changes the whole function.
So there are even and odd identities, which we don't use a lot, but I will show you a shortcut for that. You might be actually happy to know this shortcut. So we'll write them down. I don't use them very often, but you could.
And the we too, we already do.
Okay? So if this is a true statement, which it is, does this mean that sine is even or odd? Yes, sine is odd. So we've got cosine of negative theta is equal to cosine of theta. So that one's even. Tangent of negative theta is equal to negative tangent theta. So he's odd. Cosecant is negative cosecant. Now I want you to listen to me. If you look up at the reciprocal identities, you know that cosecant and sine are related. Okay? So it should make sense that if sine is odd, cosecant is odd. So secant is related to cosine, so it is even. So secant of negative theta is equal to secant theta. And then cotangent, here you go. like here's some logic for you. Cotangent is related to sine and cosine. So because it's related to both of them, nope, it's odd because it's like a negative divided by positive kind of situation. Like it's going to have to be a negative. So cotangent is odd. Trevor, your life's going to be much easier if you don't whine about this because we are going to be heavy involved in this for a while. Yeah, or more. I promise it will get easier.
No, I wish my like daily energy, but like my sports energy is not affected.
Okay. So this one you can write down. Okay. You don't have to know how to do this, but after I show you this, you might be like, oh, this just saved me some steps and I might want to use it. Okay. So let's say that I asked you to find the cosine of negative 3 pi over 4. Now, based on what we did yesterday, what do you have to do to that? Add a pi. Find his coterminal angle, right? You find his coterminal angle. Guess what? This shortcut makes it so you don't have to do that because you can use this identity here that says the cosine of negative theta is equal to the cosine of theta itself. So you could be like, oh, this number without his negative is on the chart, right? 3 pi over 4 is on the circle. So you can just pull the cosine of positive 3 pi over 4 because of this identity. Do you get what I'm saying? So you can go to your circle then and be like, oh, this is the same as the cosine of 3 pi over 4, which would be negative square root of 2 over 2. That makes it so you don't have to find coterminal angles if this angle without his negative is on the circle.
Oh, sweet.
Okay? Now, you don't have to use it. If you're like, nope, that's too much thinking, don't use it. But it's nice. It's nice if it's there. So like, for example, I'll give you one that's in terms of degrees here. Okay. So the sine of negative 240, okay, 240 is on the circle. So you can just use this identity. This says that what you do is you pop the negative to the outside. So this is going to be the negative of the sine of positive 240. Then you go to your circle and find the sine of 240. Sine of 240, negative square root of 3 over 2. So final answer is positive square root of 3 over 2. Now, if you had gone the other way and added 360 to this, you would be looking at the sine of 120. Okay, sine of 120, if I go to his sine is square root of 3 over 2. You get the same answer either way, which you have to, because that's the definition of an identity. It has to work as long as you're not picking weirdo things out. Okay, so we will progress with this on Monday. Progressing on Monday.